Hello and welcome back to the channel. Thank you for watching the previous two videos. If you haven't watched those, please do. They're in the playlist next to this video. Today we're going to make the hardware guide, and it's going to be a live chapter. This is chapter 1 of AutoHome. This is the hardware guide. What we're going to do is we're going to connect this Raspberry Pi to this relay and eventually to this 220 volt lamp. So first things first is I have to make sure that the Raspberry Pi doesn't have a micro SD card plugged in, and this one doesn't have it because I actually removed mine. This has all the software guide applied to it, and this is just the hardware. Now this is good if we want to remove this micro SD card so that we can check that everything is connected correctly before going into the software side of things, which is another chapter in and of its own. So first thing we're going to do after that is to check that all of our pins are available. And here you can see this, I have it in a case right now with a fan plugged into it, into two GPIO pins. But these GPIO pins are, I think, 3.3 volts and ground. Yeah, those are 3.3 volts and ground. So that whenever power is received to the Pi, the fan always turns on and blows air to cool down the CPU. That's unrelated to AutoHome. Don't have to know this, but I'm just telling you just in case. Anyway, a good place to start is to check the pinout of the Raspberry Pi 4 or whatever Raspberry Pi you have. You might have a 3 Model B, or whatever. This is the pinout for the Raspberry Pi 4, and as you can see, I have the fan plugged into these two ports, or these two pins, which relate to 3.3 volts and ground. What we're going to be using for this project is this 3.3 volt pin, this 5 volt pin, this ground, and we can also use another ground here and the GPIO pin number 26. This is basically what we're going to do right now. So to start off, let's put power into this Raspberry Pi and turn it on. So I have this adapter here that goes out with USB, and it's a 5 volt 1.5 amps adapter, I think. Now it might not be enough for the Pi, but to turn on everything, but we're going to use external power sources as well to help it give enough power to all of the components we're going to be using. So once I plug this in, yeah, my power cord is a bit messed up. We use converters everywhere because, okay. So now we can see the fan is turning on, and we have a little red light with a flashing green one. Flashing green light means there's no SD card plugged in, which is fine because we don't need one for now. So now, as we've thought before, the first two pins up top are 3.3 volts and 5 volts. So if we connect a cable to the first pin, which is right there, this now holds 3.3 volts, and we can prove that. We just need another cable for ground connection. So ground connection is actually the third one on the right. So this is 3.3, this is ground. We can prove that by using a breadboard without soldering anything. Let's get the relay out of the way for now. I'm gonna add 3.3 volts to the plus line and ground to the minus one, to the negative line. I'm going to add a resistor going from ground into the breadboard. And I'm going to add a yellow LED. Now, in order for you to know which leg is the positive side of the LED, bring them close together. I hope the camera can focus. Yeah, bring them close together. The leg that's longer than the other one is actually the positive side. So this one is positive. I'm gonna plug this in like so. And I hope I can zoom in. No, I can't. Okay, never mind. So the resistor is actually plugged into the negative leg, and the positive one is actually connected to nothing for now, until I give it a wire that goes from the positive side to the leg. And now it's on, as you can see. As you can probably see anyway. Yeah, it is. We can test it by disconnecting ground and connecting it. Yeah, it's on. So the Raspberry Pi always gives out 3.3 volts using its first pin whenever you give it power, regardless if there's a software on the Pi or not. Please focus, please. Okay, thank you. So next, we're actually going to connect the relay to the Pi. That's where things might get a bit complicated. So the relay here has all of these pins. We have a ground one. Sorry for the dust. Anyway, there's a ground pin, in 1, in 2, in 3, in 4, and a VCC pin. And there's this jumper here with JD VCC and VCC. We're going to explain each and every pin and how to connect each and every pin to whatever we want so we can achieve whatever we want. Now notice we have a 4-channel relay here. There's 4 different relays here and all of these logos here. We're going to explain everything that's related to this relay and how we can connect it to this Raspberry Pi 4. Now first of all, right off the bat, we can see that there's a ground pin. So naturally, we're going to connect this to a ground connection of some sort. There's also a VCC pin, which connects to 5 volts. There's also these VCC and JDVCC. We'll talk about this later. This is related to something called opto-isolation, which isn't important right now, but we're going to need it before connecting the 220 volt lamp. Now what these mean, these logos here, please focus, thank you, is the following. We have these ports here in the relay. Each relay has 3 different ports. The middle one is always called the common port. And according to this logo here, according to the drawing, can you please stop autofocusing? Thank you so much. The first one is normally connected or normally closed to the second pin. And the third one is normally open to the second pin. What this means is that whenever I give a connection to the middle one, the first one is always connected to the middle one as long as you don't give 3.3 volts into in 1, the second pin. When you give power 3.3 volts to the second pin, to in 1 here, this relay clicks and the normally open one becomes normally closed. So 2 connects to 3 instead of 1 connecting to 2. So knowing that, it's a bit complicated, I know, but anyway, knowing that, we can plug an LED positive side here is the right one because my camera refuses to focus anyway. Okay, come on, there it is. It's struggling so hard to do it. Anyway, you can trust me on this. The positive side is the right one. So we connect it like so. And now we need a 3.3 volt connection to the positive side of the LED light and a ground connection to the negative side. And so we can easily put a ground connection from the Raspberry Pi itself, which is the last pin on the bottom left, according to this diagram. See the GPIO pin number 39 here. Please focus. Why did you lose focus? Thank you. Okay. And so we can connect this wire from the ground pin to the negative lane here. Okay. Gonna move that here. Perfect. Now the positive side is gonna come from the relay itself. So we need to power on the relay using a 5 volt connection. So this 5 volt here is going to end up in the VCC pin inside the relay. So the first one here from the right. This one. So we can connect it straight away using the first pin. Color coding isn't really my thing right now, but it's fine. Now I don't have a female to female connector, so we're going to use the breadboard as a middleman to connect a female to male and then another female to male connector, so we can reach the VCC pin without a female to female connector. So we always have to go through the breadboard first. Now we connected the VCC. We also need to connect the ground of the relay to the ground of the Pi, and that's easy to do. You can just simply get ground to reach minus. You can reach it here as well. It's fine. Perfect. So now what we need is to make sure that relay 1 can switch on and off, and for that we can use the negative lane and connect that to in 1. That's here. Okay, as you can probably hear. Now it's connecting and disconnecting a lot because I'm moving the cable actually, but once I connected firmly, you can see that in 1 actually lights up the LED itself, and the relay you can hear it click. Another much more stable way we can do is the other way around, so we can disconnect the male side, which is perfect. So now we can make sure that this relay can click and the port number 2 can be connected to port number 3 here, and this can hold 220 volts. A proof of that is connecting a wire from the positive side of the Pi, which is this one, the 3.3 volts, because eventually we need to end up with 3.3 volts on the LED. But first we need to add a resistor here, of course, on the negative side of the LED to ground. This is essential so that we can limit the current that passes through the LED so that it doesn't blow up in my face. And now, if we connect the positive side, you can see the lamp light up. Now it's not a stable connection until I plug it into the breadboard itself. Now the LED lights up straight away, which is fine, but we need it to connect to the relay itself. So first, we can connect this middle port to the positive side. Let's screw it down, tighten it up. Okay. Is my voice okay? Can you chat? Because I don't know if you can hear me or not. So now after that, let's disconnect the ground connection to the relay in one pin, which is the yellow one that controls the relay. And then let's connect another wire from the normally open port, the third port here. Hey Danjay, how are you, man? Okay, perfect. Perfect, my voice is good. Okay. So now we tighten this up and tighten that one as well. These two wires, the green and white ones, are normally open right now. So they don't connect to each other right now until this relay clicks. So now this should be the positive side, and so I can connect this to this leg, the positive leg of this red LED. So now whenever I give a low signal to the input of the relay, basically a ground connection, the LED switches on. And you can hear the relay click. This is perfect. So the next step is actually to isolate the connection between the white wire and the green one from all of these little small integrated circuits and systems. Because if you give out 220 volts into the breadboard and something else is connected to the breadboard, this thing might blow up in your face. And what's cool about this relay is it has something called an opto-isolator. And what this essentially means is that it isolates the currents and the voltages running through the relay from the inside of this board. And we can take advantage of it by removing this jumper cable here, or this jumper wire. Now, as soon as I remove it, power to these relays is gone. As you can see, the LED turned off. And now, what we need to do is power the JDVCC port externally, without connecting it to VCC. Let's bring this up closer so you can see more of what I mean. I'm going to unscrew this and this one. Okay, let's remove these. Actually, let's remove them altogether. We don't need them anymore. And you also don't need this red LED because we actually tested what we need to test. Let's also remove the connection to the connection that controls the relay, because we don't need that right at the moment. And let's bring this whole thing closer. So you have the VCC pin, which controls the N1, N2, N3, N4, and the ground pin. These are all coming from the Raspberry Pi itself. And this VCC pin is the same one as this one. So whenever you give power to this one is actually giving out power as well. Now the jumper wire that we had connected these two together, like so. The jumper wire connects VCC to JDVCC. So this same VCC pin can control all of these 220 volt capable relays. We don't want that because we don't want to control it straight away, because if something backfires, it can backfire to the Raspberry Pi itself. And so we disconnect this jumper and we power this JDVCC pin from an external power source at least. And so what we can do is get an external power. This one is rated at 4.8 volts, 250 milliamps, which is more than what we need. And I cut the end of the cord here. The black and white one is the positive side. Please focus. Please, please. Yeah. The black and white one is the positive side, and we're going to connect the blue wire to it. It's a bit hard to do, but I got it working several times, so hopefully it doesn't bother me on stream. Yeah, it's a good enough connection, I think. Especially for 5 volts, it's fine. The other one is the negative side, or ground, as people like to name it, at least. So we're going to connect that. I know it's a very bad connection, but it'll do the job for us. Now let's say this is ground. Let's also say this is the positive, which is 5 volts. And we're going to connect that into a power source. Now you can't see this on camera, but the power source is a bit, it doesn't connect very well. So hopefully we can make this right on stream and not mess it up. Anyway, we can make sure straight away that my power source connects fine by connecting JDVCC to it, to the positive side, which is this one. And we can connect the ground of the Raspberry Pi to the ground of the relay, VCC of the Raspberry Pi to VCC of the relay, which is 5 volts, and lastly the control cable, which I have lost, I think. Anyway, you can use this one to whatever in one, let's say for relay 1, and to ground. Okay, so you can see the LED light up, but the problem is that the relay doesn't click. It didn't click, and I think this is due to the power, I think. Let's see. Or maybe I messed it up somehow. I think the ground connection shouldn't connect to the ground of the Raspberry Pi, but instead the ground of the external power source. Maybe. I'm not sure. Okay. That's weird. Anyway. Ah, okay. I actually switched these up. Sorry. I think, anyway. Nope, they're right. Ah, okay. So my power source is a bit messed up. Anyway, let's try and not move that. So now it works. Yeah, my external power supply doesn't always supply electricity to the board, so that's why this happened. If I had a better plug inside the wall outlet, I could have used that. It's fine. Now the problem here with all of this system, now I know it's all good, and now we've isolated these pins, these relays from everything that's power sensitive. This is all awesome, but the problem is that the Raspberry Pi, when it boots up, it always gives a low signal on all of its pins. So all of its pins are actually turned off. All of its pins act as kind of a ground connection, except for the ones that always give out 5 volts and 3.3 volts. So all of these control pins, the GPIO ones you see in green, act as ground when the Raspberry Pi boots up. And this is a problem because if you control the relay from a GPIO pin, you always give it a ground connection whenever the Pi reboots. And this makes the relay switch on and turn on whatever electrical device you have. And in order to prevent this from happening, you can use something called an NPN transistor. This thing is awesome. You have 3 legs in it, and there's no positive side or negative side because you control that. Now, these 3 legs are always disconnected from each other in a way. The first one and the third one are normally open, and the second one is the control pin. Now, what this means is that whenever you give 3.3 volts to the second pin, the first and the third connect together. If you give a ground connection to the first and the third, you wire it up to the relay and you give 3.3 volt to the second, now the ground connection connects to the relay and the relay clicks on. And so that you can turn a 3.3 volt signal into a ground signal. And we're gonna use that now. So now the relay, instead of connecting to the ground, we're going to connect it to the third leg of the transistor. Let's move the transistor a bit so we can have more room. And we're going to put a wire from ground of the Pi to the first leg. Keep in mind they are not connecting together, so the relay will not click. So now ground here goes to the first leg. So now whenever we give out a 3.3 volt signal into the second leg, the white wire and the orange one here will connect together and give a ground connection to the relay. Let's test it. This is my 3.3 volt connection here, and we're going to connect it to the middle leg, and the relay clicks. Now, knowing that we've opto-isolated, it's a big word, I know. We've isolated all of this power-sensitive components from the relay that's power hungry. We're going to connect a normal room lamp in this side and see if my Pi can turn on a 220 volt AC connection or component. So let's turn off the relay here. Actually, yeah, I'm gonna turn it off completely. Now here, I think it got a ground connection for a moment. It's fine. It's not a big deal. When you connect something to it, it'll short out and it's fine. It's gonna be fine. I think anyway. Yeah. Okay. So I have this room lamp and I have it wired up to nothing as well. On this side and to the mains on the other side. I know it's a bit dangerous to do that, but we're gonna make sure that these exposed cables are actually neutral ones and not live ones, so that we don't get electrified. In order for me to do that, we're gonna use a testing cable, testing a screwdriver. This one lights up whenever it detects a live wire. So we're gonna connect this to mains. It's a bit dangerous, but you're gonna wait. You have to wait a bit. It's all good. Okay. Perfect. So now this is the live cable. I've actually unplugged it from the mains, so don't worry, I can touch it. And we're gonna connect this one to the common port. This is the second port on the relay. We're gonna be very careful so that we don't expose any small wires that can turn on the lamp unintentionally. Let's tighten it up. Okay, perfect. Now it doesn't move. And whoa, okay. It's a bit finicky, but it'll do the job because this table is a bit slippery. It's fine. This is the lamp. It gets a neutral connection straight from my mains, but the live connection is gonna be controlled by the relay. This is the normally open port here. All right. Now let's test it. And I've plugged the power. So the one that's labeled in blue here, I don't know if you can see this. Yeah, anyway. This has live connection right now, and you can test it by connecting the testing screw to it, and I think it'll light up anyway. Yep, it did. It's a very faint light. You might not see it on the camera, but it's connected. And so now, and now we can see if the relay clicks whenever I give the NPN transistor 3.3 volts, and the NPN transistor can connect both ground connections together. Hopefully it doesn't blow up in my face. Yep, that's it. This is perfect. So I know it's a 30-minute live stream, but it's fine. What we've actually did here is a perfect step forward. So let's review what we did here. This Raspberry Pi always gives out 3.3 volts into this yellow wire. Let's turn off the lamp so that you can see it clearly. Okay. Okay. So now 3.3 volts are always connected to this wire and into the red line of the breadboard. Ground is always connected to this gray wire into the breadboard as well. And when we connect these two cables into an LED light, this LED light turns on. Let's replace this with the red one so you can see it clearer. This is positive and negative. Okay, perfect. You can keep this plugged in at all times so you know that there's power into the Raspberry Pi. If you don't want to look at this small red LED here inside the Raspberry Pi. So it's fine. And now the relay connects to the Pi using the N1. This is the control of the relay number 1. It also connects to the external power source using JDVCC that gives me 5 volts to control the relay. Ground connects also to the external power source so that you can isolate anything that's power hungry like this lamp. And VCC, which is the power of all of these pins except the ground one, connects to the 5 volt connection of the Raspberry Pi. This wire always gives out 5 volts. Now the problem here is that the relay accepts a ground connection from its in port to switch on. So you need to give a low signal from the Pi to the relay so that it clicks on and turns on the lamp or the AC unit that you want or anything you want to make smart. But the problem here is that if we control the GPIO pins that you see here that you can control, if you control them using software, whenever the Pi reboots, it always gives out a low signal out of its control pins. So this always clicks on and turns on the unit that you want to make smart whenever the Raspberry Pi turns on, and we don't want that to happen. So we need to somehow control these control pins on boot. And to do that, we know that whenever the Raspberry Pi reboots, it always gives out a low signal. We need to make this low signal be useless and always convert the high signal into low so that this clicks. I hope I made sense. So I connected this green wire into ground, which is a simulation of a low signal. And I'll connect ground to the second leg of the NPN transistor, and nothing happens, as you can see. Whenever I plug it into the 3.3 volt, the relay clicks on and the light turns on. So this NPN transistor kind of converts the logic into whenever I boot and give out a low signal, don't do anything. Whenever I give a high signal, connect both ground wires together so that the relay turns on. Now, yeah, I know there's a delay between me disconnecting and it turning off because this is a ground connection, and so it's a low voltage connection. So it takes a while to regulate its pins and shut off. It's fine. So thank you all for watching the stream. I know it's not much, but hey, we did something. So now whenever I want to control this NPN transistor, which controls the relay itself, I can connect GPIO number 26 here, which is the second one from the bottom left, into the middle leg of the NPN transistor, like so. This is the middle leg. And this goes to GPIO number 26 here. I know you can't see it, but trust me, I'm connecting it right. Alright. So this is the hardware guide. This is what you need to do to connect everything together. Now GPIO number 26 sends a low signal on boot and stays low unless we control it using Python, and that's gonna be the next chapter, the chapter 2, the software guide, and it's going to be, I think, split into 2 parts because it's a big guide. And well, actually, let me show you real quick what I did with the software guide. I'm gonna unplug the Raspberry Pi, turn everything off, and I'm going to plug in the micro SD card here. Okay, and I'm gonna give it power. Whoops, I have no idea what happened. Anyway, Now we can still test it by connecting this pin here to positive. Perfect. Now we can put this here. Okay. Now my Wi-Fi is a bit far. The Wi-Fi signal might not be perfect, but let's see if the Raspberry Pi actually connects to my Wi-Fi network and goes online. I have my trusty OnePlus 3 here. And I can use MQTT to turn on the relay, on and off. It actually connected, nice. So this is how you can control the GPIO pins remotely with software. Let's turn this around like so. Whenever I turn on the AC unit here, as I like to call it, which is replaced right now for testing purposes by a normal room lamp, you can turn that on and off. Alternatively, which is also pretty cool, you can actually turn it on using my watch, but right now I don't know if it's gonna work because I'm not connected to Wi-Fi on my phone, but let's see. It's a bit slow. Yeah, it works. It doesn't always work, but yeah, it works. It's a bit slow because this is actually connected to Bluetooth BLE, which is Bluetooth Low Energy, and there's a bit of a high delay because there's a lot of processing involved. This actually connects to an application on my phone, which is Notify and Fitness, and sends out a signal. Whoa. And sends out a signal to Notify and Fitness, and this app connects to IFTTT, which then connects to Adafruit IO, and then connects to the Pi. It's a long process, and you can skip most of that by just using an app that connects straight to Adafruit IO, which turns on and off the lamp. Now, Adafruit IO has a bit of its limitations because you can't spam it. You'll get timed out for 10 to 30 seconds, maybe a minute even. So that's why we actually turn it on and off a bit slower than usual. See, not always. It's not always updating because I might be throttled here. This isn't a problem with the project of mine, and it's not a problem with Adafruit IO itself. It's a problem because I give out a lot of information from my Raspberry Pi to Adafruit IO, which I'm going to be explaining um, after we finish this AutoHome project. There's a lot of stuff I actually put inside this SD card that gives out a lot of information to Adafruit, and I get throttled if I spam it a lot. You, on the other hand, if you want to apply this project alone, you can spam it, or you can just buy the Adafruit. I think it's called Adafruit IO Plus, which gives you unlimited access to these. So thank you all for watching. I hope you enjoyed this long and painful hardware guide. If you have any questions, I'm gonna wait about 5 minutes, let's say, and you can ask anything and I can answer. If you want to know what this switch is, this is actually the master switch. I hope the camera focuses. Yeah, this is the master switch here. So whenever I shut this off, I can no longer control the AC even if I clicked it. It never goes on. So whenever I click master on as well, it'll turn off and turn on and off the AC anyway. So now I think I got throttled. Yeah, I got throttled. Does it blend? I think so. I mean, you can blend the lamp for sure. This is a fragile one. Yeah, see, I got throttled here because a lot of information are going out of this. What I added here, more than the pins, are actually temperature, a temperature graph for the CPU, and a voltage monitor, kind of a finicky gold voltage monitor. It actually uh, it actually monitors the LED light here, the red one. Whenever it shuts off, I can know. Yeah, it refuses to turn off, probably because I'm being throttled. Actually, I can check. Hold on. Yeah, I turned it off manually. You can see it. So you can see it here. Let me just. Okay. Yeah, this thing disconnected, I think. Anyway. Here, it's a huge laptop, but anyway. This is the Adafruit that doesn't want to focus. This is the Pi temperature. It's right around 40 degrees right now. This is the clock speed of the CPU. And this is the voltage LED brightness. And you can control everything from here as well. So we can turn on the lamp. And then you can turn it off as well. This is Adafruit, straight from Adafruit. So this is, I think, the fastest connection you can ever get from an online MQTT based service. If Adafruit ever went down, you can create your own MQTT server, which isn't that hard to do, but you need a real IP. Grey Cat Grey Hat asks, what is the switchboard? I missed the first one of the stream. You have a link to it. The switchboard. You mean the relay? Is that what you mean? The relay is actually something I bought in a shop. I think this is actually something made in China anyway. It's a cheap relay. Now it says here that it supports up to 250 volts AC, up to 10 amps, but I don't trust it to turn on a 10 amp power hungry component because I think it might blow up or just uh, not be a good isolation between the Raspberry Pi and the relay. You can find it anywhere online, from Amazon to AliExpress or something. You can buy it off of anywhere online. Yeah, it's a high voltage relay here. You can buy it as a single relay, so just one channel, and I think dual channel 4 and 8 and 16, and it just gets bigger with more pins. I just got a 4 channel relay here, so I can control 4 different components at the same time, essentially just with a single board and with a single power source and with a single VCC pin. I can just add more pins here into the board and more NPN transistors here into the breadboard anywhere, and we can control it instead of controlling only GPIO pin number 26 using the software guide, which I'm gonna do later on next week. We can control maybe 17, 27, 22, or maybe 5, 6, 13. We can add it all into 26 so that we can control more components. Um, this is why I've actually put knowing Python coding into the requirements, because you need to actually edit GPIO number 26 here inside the Python code into something like GPIO 13 if you want to use that, or GPIO 17 if you want to use that, or any green GPIO pin. So yeah, it's a high voltage relay. That's the simple answer. Okay, so I guess there's not any more questions, I think. So I'm gonna end the stream. Thank you all guys for watching, and I'll see you next week with the software guide, part 1 and part 2. See ya!